So thanks for listening in today. I've got a few things to talk about energy. I've been working in the energy industry for around 30 years, both in the built environment and in the data center and pure energy infrastructure. Talking about what's going on at the moment. Hopefully you'll learn a few things, but if nothing else you'll learn about today is you'll realize I'm quite passionate about all things energy, and I do love a graph. So apologies for that if you're not a graph fan like me. So in today's world, I do want to sort of kick off with a sort of a bit of a positive note about the UK. And if you didn't know already, a positive thing about the UK's energy industry is it's decarbonised its electricity grid faster than any other major developed country in the world over the past decade. And that's helped by, of course, us being able to get rid of coal, get rid of some poor open cycle gas turbines on our grid, and of course our ability to capitalise on our greatest natural resource in the UK, which is wind and a bit of solar. And that's a positive thing, and we really should be proud of that. And that's something that we should be using more of because it helps the UK attract new business. So something else to just to frame energy a little bit more, and I think it's important to know this, is that of all the global warming emissions, and that 73% of that it comes from energy in some sort of form, and admittedly, energy is linked in all sorts of things, be it the tractors and the petrol and the diesel in our tractors, through to things like our building use, the transport industry, and the large industrial factors that we've got across the globe, kind of thing. And what I would say there is that certainly for the built environment, I think energy use is becoming even more important. When we talk about transport, that moving over to all electric, a large proportion in the future of electric cars could be charged at home, so that binds it with there. And also industry is still within the built environment. It's still within factories, which are buildings themselves. So I do think the built environment is really important and the biggest part of that. So there's your first graph, and a reason why energy and is the big focus for sort of dealing with global warming emissions. Here's another one which I absolutely love. UK energy use from its source, and the size of the box represents the amount of energy that is consumed and used from that resource. Now you can see there that petrol is the biggest one, diesel, petrol for all our cars. Then you have natural gas, obviously for boilers in our homes and for large industry that's still heating with that. And then probably only a quarter is used in electricity, so air source heat pumps, lighting, and other bits and pieces around there. And there is some biogas and coal. This is a couple of years out of date. Coal has now pretty much disappeared. It does exist in a few instances here and there around. A few old buildings are still, believe it or not, still running on that. In fact, some hospitals are still running on coal. Um, uh, what is important and really important, and this is sort of the big driver for some of the challenges we're facing right now in the UK, is that as we decarbonise, the grid has to. We know that we're going to adopt electric cars, and a large proportion of that petroleum is going to become electric. So effectively, that grey box is trying to fit into the yellow box. And then you take up natural gas, for example, and we're going to air source heat pumps in our homes, and the industry is switching over from boilers to air source heat pumps as well. So a large proportion of that blue is trying to fit into the electricity. And that's a challenge because our grid can't suddenly get that much bigger. We are helped, of course, that the electric cars are significantly more efficient than fossil fuel cars, 3 to 4 times, and it's getting better as cars and technology is improving. So effectively, you're sort of saying a third to a quarter of the size of that grey box only has to fit inside electricity. And then the same for air source heat pumps. A well-designed, properly installed air source heat pump will be 3 to 4 times more efficient than a gas boiler, and that's trying to fit within the electricity grid. So it is helped, but it does mean there is still an awful lot of pressure on the electricity grid at the moment. So just to summarize a few things and just to talk about how we sit on the global scale at the moment. So as I said, the UK's decarbonised faster than any other developed nation. That's a good thing. The UK has committed to being net zero in its grid by 2035. Another good thing. Will we achieve that? Well, there's definitely some challenges, and I'll come on to that in the future. What I would say, though, is that the UK, as I said, has access to some of the cheapest form of energy compared to most other countries in the world, and that is wind, and particularly onshore wind. And if you take a look at an example of that, you take a look at Scotland right now, where it's only 21 grams of CO2 per kilowatt hour. And you compare that to other global areas, and that goes, well, if we can repeat what Scotland are doing and get that energy to the rest of the country, we can stand proudly above most other countries, which is a good, attractive area when we're trying to attract energy-intensive industries, particularly things like data centers. The downside of that is that, of course, the UK's retail prices for energy are one of the most, if not the most expensive in Europe and East Africa, Asia areas, which is a frustration given the fact we have access to the cheapest form. So we have to change that, and we are. But at the moment, it's in a transition, and that transition is causing a constraint on the grid. So I want to put that in some more visualizations, because I think this is really important for people to understand. So take our grid, and if you were to ask our grid to absolutely max out its theoretical maximum capacity, it's around 63 gigawatts. In reality, it doesn't typically go beyond sort of 40, 45 gigawatts. And I think that's what it was in 2025 in terms of data. So you compare that against people that are trying to apply for grid connections, right? And this is as of November last year. That's sitting, so applications that were paid for, signed and accepted and waiting for their delivery date were sitting at 120 gigawatts. That's made up of EV charging, master plans. A large proportion of that was data centers and all sorts of different industries trying to get power from our grid. That's twice the theoretical size of our grid is ever capable of delivering. That's problem number one. On the other side of that, though, applications for generation and storage it was more than 10 times the size of our grid. And these are people that have paid their money, done their studies, made their applications, and waiting for a date. And that back in November was an absolutely ridiculous state to be in. And there's no way we can deliver that. And in fact, that generation and storage queue was 3 times more than what we need to meet net zero. But things have changed. And as of about 2 months ago, a lot of those projects got kicked out for a number of reasons. One, they were just speculative. Two, they weren't developing fast enough. And three, they were simply, more importantly, we don't needed them. We didn't need more batteries. We had enough batteries already waiting to connect, which were further on. We didn't need at the immediate time, certainly for the next few years, more wind in Scotland right now, because we can't get it out of there, as we know. So that's dramatically dropped. So there's a lot of projects that have had a lot of bad news, and that's not a small figure. That's an enormous figure to lose out of the grid. Demand applications have also gone through the same thing. So they have reduced from 120 down to 99. That's NESO kicking out the queue those that are purely speculative. And those that are literally just trying to do land bank and make money. Now, out of that 99 gigawatts that are left, the view is that there is about 50 gigawatts of that is just data centers. And those data centers are of varying degrees of progress. A lot of those, again, are people that are just simply going, if I've got power and I've got land, I can sell it for a premium right now. So that's going through a reform. And the view as NESO is, I think, a good sort of 30 gigawatts of that are not true projects, and they're just trying to make a fast buck. So those are likely to get kicked out. But nevertheless, even with those resulting numbers, there's still a big challenge that's facing the UK at the moment. So if you are a project trying to get a connection in the future you're up against some stiff competition. And that's the challenges. And that's why people who want a connection have been told that they're not going to get a connection for 5, 10 or more years, which is a very difficult position if you are trying to invest in the UK. I'm going to come back onto that because out of this crisis can come some real positives. So just to summarize where we are. So the UK's energy system's a bit of an inflection point. It's undergoing an awful lot of stress at the moment. There's a lot of problems on. I know NISA and NJAT are under a huge amount of pressure to meet both the demands and decarbonisation. And I would say it's not just a temporary situation. This is a transition. This is us decarbonising. It is painful, but we have to work with it. We have to use what we've got and capitalise on that. So just to cover a couple of things, I want to talk about the energy industry. We work with the energy industry. You see the profits that it's making, and we understand how it can be used and what a fantastic thing it is. I work in the built environment, and I see the profit margins they make, and I know the energy industry makes a significant higher margins on this. Here's a couple of examples just for you to understand and gauge this. So a typical warehouse, I say typical, it's a big one. If you weren't just going to cover it with a few to meet your Part L requirements, PV panels, and you actually maximized it and you use that revenue that you get from it and sold it in the best possible way, you can make from just the roof over £250,000 a year of that warehouse from the roof, from the energy on that. And that's, for some warehouses, is a large proportion of the profits that the landowner will make. And that's a huge thing that you can do for that. Right, done properly, monetized correctly, of course. The other things it can do is reduce your peak import power. I know the sun doesn't shine all the time, but you can couple it with batteries. You can use it in particular ways. You can do storage, all sorts of things that you can do that can help manage that. And of course, it helps reduce CO2 emissions. So there's ways of doing that. And the key here is to try and do it simultaneously. Bring those things together: capacity, cost, and carbon, to find the balance. Battery, for example, a 20-foot shipping container. Nowadays, you can fit 5, 6, 7, 8 megawatt hours inside a 20-foot shipping container, which will fit on a car park space. Done right, maximized, use in the right place. We've done systems that generate over £200,000 a year just from the battery. And the IRR playbacks from those can be really good, in the right place, in the right location. And then they're really good at helping manage peak demands. If you have a peak demand on your grid, on your building, but you have a constrained grid, you can smooth that out, get your connection quicker. So they're a huge benefit for people. And again, they can store energy when it's low in carbon and playing back when it's high, so it can help reduce the CO2 emissions from yourselves. And again, finding the balance. And the last one over energy for revenues, which is a big one right now, is EV charging. So when we've looked at some data over well-monetized, well-placed EV chargers, if you use them, you go, crikey, these things are expensive. Electricity to generate only costs about 5p. How come I'm paying 80, 90p or more for a kilowatt hour? Well, to be honest, done well, you can make a lot of money out of this. Not all locations, but done well in the right location, you can generate decent revenue from these things. Doesn't have to have an impact on your grid. If you couple it with storage and you actually work with the grid, not against it, and it helps with CO2. And again, finding the balance is the balance. So there's huge opportunity with energy for those who want to step out of whatever their environment they are, whatever they are, built environment, data centers, whatever they are, manufacturing, and actually capitalize on the revenues that are available from energy. So going back to where this image here, your project struggling. Right now, there are a huge number of projects that are basically worthless now. They're not going to get a grid connection, these generation storage. And those projects there, if you could link with them and actually find a way to link your project to them, and not necessarily be entirely reliant with the grid, and work with the grid with that generation and storage. And that might be PV on the roof. It might be private wire. It might be working in collaboration in a cooperative way with energy assets. It might be a community, all sorts of methods that work with the grid, not against it. poses one of the greatest opportunities I think the UK has got within the energy industry right now. And this is a really hot topic. We are on every project we're working on. This is the way to unlock grid constraints. This is the way to help lower the cost of energy and make us more competitive than our European or international countries, and help other benefits in terms of the overcome grid constraints as well. I mean, this is just an extract from a map that we have. It has all of the substations, every cable in the country, and this is just one output from it. The orange dots there are all the generators that are sitting in that queue that are waiting for a connection. And that's a huge number. You're never far away from somebody who'd be probably quite happy to help with providing you energy. And we match this and we do look at areas and other such things. There's about 15,000 projects. So there's probably something not too far away from you that you could use. And about 3.9 gigawatts worth of energy that's available for you to knock on the door. And I'd probably be quite happy to talk to you about these opportunities. So there's great stuff going on there. The last thing, we're coming to the end now, is just if there's something you take away from here, as you know, I'm passionate about energy. I really want people to value it in a different way, and I value it. And the strapline is to consider it on those 4 C's. It's capacity, how much is available, and that includes resilience and other such things. That's an important thing, and not asking for more than you need. Working out and working with the availability on the grid and matching your demand with the availability of the grid. So capacity is a really important way to value energy. It's cost, of course, that's very important. Carbon, understand the carbon. We are trying to work, obviously we're working towards net zero. We see people using diesel generators and gas generators to overcome this. I don't believe that's the right answer. You can do it with renewables. It is possible to do this, and there's some projects that we're working on now that's proving that. And yes, of course, these renewables are a bit of a eyesore for some people, so we must engage them in the community aspect, let them benefit from it, think about community needs, engage them in that way, and finding the balance for what's right for your project between the capacity, the cost, the carbon, the community is the thinking that needs to be done. Where do you sit in there? What are the priorities? What works for your project? We've developed a model, and just not going to go on about this, that helps do this. We've called it the golden thread, that helps people identify those assets, work with them, find out what's the optimum mix, and deliver to your site, working with a grid, not against it. And that is a really valuable tool to be able to use and offer for people. And the last thing that I've got here is just that we've done a little article. Please feel free to have a look at that. We called it Jumping the Big Energy Queue, which is classic for for the UK, for standing in queues. There are ways to do this. It's not the golden ticket quite, but it really can help in a lot of instances. So that's it for me. Back to you, Jordan. I don't know whether we had any questions that have come in.
The quick question that I want to ask you is, obviously, as buildings become increasingly electrified, that's one thing we're seeing. Where do you see the biggest opportunities for organizations to unlock value from the energy market?
So take a look at at your energy supply and look at it as a proportion. So there are different industries. So if you're an office is its energy supply is probably really small. So the opportunity around that's going to exist. But maybe you're an office with a car park spaces and other such things. There is where your load can significantly increase. So how do you use that? How do you monetize it and other such things? But other industries, it's different. I mean, residential, we've seen the rollout of PV and how people are managing to maximize those benefits around there. But other industries really can take a look at the mix, take a look at the share. A data center, 98% of their operational cost is energy. So the thinking has to be done. So you have to value energy that's right in those markets. So I think you have to look at what you're building, look at how it's interacting with energy now and in the future, and how can you maximize those revenues, be it the roof space, be it with your neighbors, be it from the heat systems, be it from EV charging, be it from energy storage. All of those aspects, take a look at those, use the 4 C's as a bit of a guide and go, well, how can I use those as a benefit for me?
Do you also think that with the grid connection queue being as long as it is, we're going to increasingly see more like private wire projects?
Yeah, I do. I want to see this because ultimately private wire, and I know people will probably be a little bit cautious about this. Does this mean I'm going to end up with pylons all over the place? Is this going to end up with some sort of cowboy kind of energy industry going back to what it was, 100 years ago? I really don't think that is, because we can work with the grids. If you have a connection, ultimately what you're doing is you're bringing forward renewable assets. And this is really
Mm.
important. You're bringing forward renewable assets, optimizing those with your demand, which if you do in a building with a demand, you can optimize the use of the energy far better than the grid can do it.
Yeah.
And by doing that, you're making sure, and I'm always an advocate of, for every pound you spend on energy, you get the best bang for your buck. And you can get the best bang for your buck in terms of doing private wire. And that
Mm.
done right can actually help the grid. You can use your grid connection to get renewables onto the grid and not ask the distribution network operators or national energy system operators to put in separate connections. That's
Yeah.
inefficient. They haven't got the time, they haven't got the resource. We don't have enough engineers. So it's a no-brainer, in my view, to not reuse those existing demand connections for the generation at the same time.
Yeah, I absolutely see that. We have had some questions now.
Great.
Ben Lane from Climate Create says, "Is there a repeatable model for providing EV charging locations with energy storage across the country with no major grid connection issues? So less than 1 megawatt connection."
So is there a model for that? Sorry, was it? Sorry.
Yes. Is there a repeatable model?
Uh, Right, there's data sets, and this is the issue: is that every area has its own constraints. And on that map I put up there, we actually map every single substation and its available capacity. So if you've got a site, please just get in touch, and we can actually tell you where those capacities are.
Mm.
Typically, though, below 1 megawatt, you tend to find the distribution network operators almost have to give you that connection. They hold capacity in reserve. Okay, there has been some constraints and other such things, but you can overcome those. There's tools around that to overcome it. So it's a case by case basis. If you're under a meg, you've got a much higher chance. As soon as you go over a meg, and potentially, and the next step is 5 meg, you start going to territories where it will be more of a challenge, and don't
Mm.
expect it. First thing to do is engage early. There's lots of data, and actually from the 1st of April and going on throughout this year, the data availability is improving, which allows you to make informed decisions about grid connections faster.
Perfect. Thank you. And we also have had one from Elena Andre. She says, "Laurence has just said about applications for more power than the site customer needs. How can this be controlled/stopped? Asking the question with my hat of an electrical network planning engineer."
Okay, so I know that some of the DNOs have started doing this now anyway. So they've certainly brought in a new set of criteria that makes it, you have to provide more information. So I have a request to DNOs to not just have a box of how much power you want. That's the wrong
Mm.
answer. It's how much power do you want, when do you want it, and when can you do it without it?
Mm.
That's the questions that need to be asked by the DNOs, because it incentivizes people to shift, it incentivizes people to use the DNO network more efficiently. There's a bit of legislation that has to catch up in the background around that. But that's a request, and we are finding the DNOs. They've changed their name from distribution network operators, which is the SSEs, UK Power Networks, to DSOs, distribution system
Yeah.
operators.
System
They changed the name, but we haven't seen the demand side catch up with that. Yes, they're controlling their generation, and I get that, but active network managed demand has to come in, and certainly for the right kind of projects, because we're screaming out, we're happy to do it because it makes economic sense for a development to do this and install systems to turn power down and turn it up. And just one other point on that is that when I've spoken to Mark Adolphus, UK Power Networks, and other DNOs, they all tell me that when people apply for power, they, on average, they apply for and get connected for twice as much as they ever use. So you're over engineering. Stop that.
Mm.
Work with data. Use a proper consultant to help you understand the data, and stop thinking about, well, if I can have more power, my asset is worth more. We've got to
Mm.
overcome that, because you've got to value energy differently and stop doing those things. Okay.
And obviously, in the next session, we're going to talk a bit about flexibility. Obviously, that's hugely important these days in terms of, you say using data. Having that ability to be flexible is using data.
It is, yeah. It's access to the data. The DNOs are opening that up, and I know there's people lobbying very hard to get better data from there. We all need better data. We've been collecting it, but data has now become a valuable asset. So if you have that, you can use it, and you can take, I wouldn't say risks, you can make better informed decisions over that, and
Mm.
ask bravely, perhaps for some, ask for half the amount of power and not pay for those reinforcements. So.
Yeah, it might save you a bit of money, and you realize that that's actually all you needed in the first place.
It is, yeah. It costs you very little just on data.
Yeah,
So yeah, totally agree.
exactly. I'm going to ask one more question because I know we've got a few more minutes. What do you think are the most significant barriers preventing organizations from adopting a truly all-electric approach today?
I think price of energy, that's the first one.
Yeah.
And obviously the immediate availability of grid connections and that process of getting it. I think that's the two biggest barriers. Um, and to take a wider approach from that, and a bit of a beer on our bonnet, is the lack of forward investment that has existed in our energy networks has
Yeah.
left us with this. It's always been borne by the developer, those that were wanting new connections, and very little, well, hang on a second, if they're going to put a cable down this road, let's put in two, let's put in the
Yeah.
next bigger one. Because we all pay for, if you put in more and it's not used, we pay the bill on our bills. That has to be
Yeah.
maintained. That capital has to be done in our bills and our dual charges and other such things. But now is a no-brainer. We know we're going all electric, and now is the time to invest and stop putting in exactly what you ask for and put in what we think is the right thing. Because right now, you put in power, people will come.
Yes,
Yeah.
absolutely. You say a price of energy there, being one of the big constraints. It's one of the reasons that OpenAI decided to not build its
Yeah.
Stargate project. I think there are probably multiple reasons why they
There are
didn't
multiple
build that
reasons
in the
for
end.
that. But that one
Um,
is exactly the case, that we're building models now, and we're doing another site that is completely challenging that. And that will go
yeah,
public in the next couple of months, which will hopefully turn the tide on that and show that no, the UK is actually the cheapest form, because we have access to the cheapest form.
we do. An abundance of renewables, which not
Indeed,
many
we do.
countries
Yeah,
can argue. All right, thank you for that, Laurence.
no problem.
Really appreciated. Obviously, anyone that wants to catch Lawrence's session again, it will be recorded. Well, it has been recorded and will be available very shortly. Thank you for joining us, Laurence.
Thanks all.